Okay, this is a new derivative, right? We never learned this one. We learned the derivative of e to the x, but we never learned the derivative of natural log of x. Well, here we go. Derivative of natural log of x is 1 over x. And the derivative of natural log of the absolute value of x is the same thing. Okay, so this is one of those weird instances where absolute value doesn't change anything. All right, so this is the chain rule version on the right hand side. All right, let's continue. So derivative of natural log is 1 over what's inside, then times the derivative of the inside. Derivative of 5x is 5. Well, you clean that up, that's 1 over x. That's it. B. This one requires product rule. So I'm going to do x cubed times the derivative of natural log of x, which is 1 over x, plus derivative of x cubed, which is 3x squared, times the natural log of x. And x cubed over x reduces, so it's x squared plus 3x squared natural log of x. Final answer. C. All right, so this is one of those weird cases. You're thinking, oh my gosh, why do I want to do that? Well, you don't. You don't want to take the derivative of that. What I'm going to do is first use the properties of logarithms to split it up, okay? So if you don't remember the properties, we'll take some time to review them sometime. So this is natural log of x squared minus 5x plus 2 minus the natural log of x minus 3. So if you recall from the old days from Algebra 2 and Pre-Cal, the properties of logarithms, if you have a quotient, you can rewrite it as a difference. Now apply, so this is not a calculus step, this is an algebra step. Now we can apply chain rule on these. So take the derivative of that, which is 1 over x squared minus 5x plus 2 times the derivative of the inside, which is 2x minus 5, and that goes in the numerator, minus 1 over the inside times the derivative of the inside. The derivative of the inside is 1. So that's it. That's an acceptable answer right there. I probably wouldn't leave the 1 out there. Just make that go away. So just 2x minus 5 over x squared minus 4x, 5x plus 2, minus 1 over x minus 3. That's it. That's a good answer. Let's go with D. Power rule on this. So g prime of x, bring down to 4, keep the inside, subtract 1 from the exponent, and then what's the derivative of natural log of x? It's 1 over x. So I'm just going to put it over x. And that's the answer. H. All right, so I'm going to rewrite this as natural log of x minus 5 to the 1/3. Remember, with the properties of logarithms, you can bring the exponent forward. So it's 1/3 natural log of x minus 5. All right, so now I can use chain rule on that. 1/3 comes for the ride. And the derivative of natural log of x minus 5 is 1 over x minus 5. So the x minus 5 is in the denominator, times the derivative of x minus 5. Well, the derivative of x minus 5 is 1. So that's it. That looks kind of funky, so I'm going to rewrite it again. So it's 3 times x minus 5, like that. That's the answer. F. Let's leave that alone. Derivative, 1 over the inside times the derivative of the inside. So it's over, or 12x cubed. Reduce that. The 4 over x. That's it. There is a properties of logarithms lurking in there, but you could have done that just fine. All right, okay. G, you want to use the properties of log. Okay, so remember that square root is same as to the 1/2 power. So I'm going to do all this in one step. X squared becomes 2 natural log of x plus natural log of x minus 4 minus, and minus because that's in the denominator, 1/2 because the exponent of square root is 1/2 of natural log of x cubed minus 10. Now I'll do the log separately when I take the derivative. So derivative of natural log of x is 1 over x, so it's x, and the 2 comes for the ride. Derivative of natural log of x minus 4 is 1 over x minus 4 times the derivative of x minus 4, which is 1, minus that 2 is going to go in the denominator. Derivative of natural log is 1 over the inside times the derivative of the inside, which is 3x squared. That's it. That's the answer. H, final example. Again, do some logarithmic rewrite. So I'm going to rewrite that. So this is not calculus yet. So that's r plus, that's a cube root. So it's 1/3 natural log of r plus 2 minus natural log of r, right? I guess I should just cancel that, all right? And minus natural log of r minus 1 minus natural log of r plus 1, right? All these minuses because they're all in the denominator, okay? Now let's take the derivative. So this, we should just cancel those, all right? So it's going to be 1/3 or 3. Derivative of log is 1 over the inside, so put the inside on the bottom. And derivative of r is just 1. Minus over r minus 1. The derivative natural log of r minus 1 is 1 over r minus 1. And this is minus 1 over r plus 1. And that's it. And that's page 116.